Okay, I'll just do this quickly. Have a few things to cover. Just start this, made some updates to this face recognition delegate. It's delegating for CPU. Is it running? I have to stop it, Control C, just run it again. So that's the old one. It has face in green, left and right hand in yellow and red. Yeah, sometimes we'll get confused. We'll either lose the hands or think left is right and left. I saw it the other day. But otherwise it's fingers crossed. Fingers crossed. It's all good. We did some update to it, so this one, yeah, even if you try to close this window, it doesn't close. You have to hit the Q button, which is fine. We can change it later. This one is a modified version of the same thing. The lines on the face actually in blue, and they are lines. They're meant to be. The idea was that they go angled towards the outwards. Yeah, see here it confuses left for right hand when the color changes to yellow. Now on this hand you can see the numbers indicating each marker, so that's quite handy because we're going to be using it for the sign detection. So I'll just pop this one here behind me. I think I need that window open. It's also another thing, if you minimize it, it stops running as well. And so we trained a transformer model. This code is of Kaggle. It's the competition example tutorial. It was running for half an hour, just finished. So for this code, just quickly go over it. Yes, we're using American Sign Language, finger spelling recognition using TensorFlow. So we installed all these different packages. MediaPipe is what does the images. OpenCV, Matplotlib, TensorFlow Keras, Scikit, Pandas, Seaborn, PyTorch. Yeah, the whole lot. I think some of them were actually not actually using. Surprisingly, this Jupyter notebook gives some warnings for, well, for example, this TensorFlow Keras. Yeah, it's probably, and then so we have the Copilot, GitHub Copilot running, so you can explain the error. It will do it in the Copilot chat. Keeps always saying that you have to install, upgrade TensorFlow. But then we might, which we did multiple times, it should be, that's fine. I might having some issues with directories though. We have all the necessary dependencies. Anyway, regardless of this warning, the code is executing okay. That's the TensorFlow and MediaPipe versions that we use. We're loading the dataset. We have the dataset locally. We're running this locally as well. So I'm just digressing again. We could run this code on a Kaggle itself. Well, some things, there's like limited resources that you get. That's what's currently being used. But then you also have you can max out on those, and there's also condition for the competition for, I don't know, I'm pretty sure you can use GPU. I don't know why it wasn't using it yet. So you have current use, what you're currently running, and then you have overall, I don't know, I think it's throughout the day. So maybe we'll try to compare if the results are any different. We'll try to compare what the Jupyter online Jupyter Notebook does versus what we have running offline. It's all these Parquet files. You have these phrases that people spelled out using American Sign Language. So you have the ground truth labels for the location of the fingers. So the X, Y, Z, the Z being told not to use the Z coordinate because it's inaccurate, but the X, Y should be okay. So that's what the data looks like. Then you have this thing about the dominant hand, because I guess sometimes when spelling letters, there was a previous competition where you had to detect whole words, so that would be different. I don't know if both hands are being used. I was actually thinking on bionichaos.com adding a tool that will actually help you learn sign language. If anyone's keen, let me know. Also, if anyone knows sign language, it would be really nice to get feedback. So we're loading the data here, matplotlib, for plotting this graph. So that's what you have this 21 key points on the hand, landmarks for left and right hands. And yes, you need to, supposedly when spelling out, my understanding is that you will use one hand at a time kind of thing, but then when one hand is tired, you will swap and use the other hand. So there's a bit of code that determines which hand is dominant. And this is an example of what it looks like. So yeah, it's just a snippet. And you see, in this case, each finger is different to what I have running for the camera footage processing. This one is labeling each finger in different color, and the palm of the hand in blue, and then each finger in a different color. I don't know what that image is. We pre-processing the data. I don't know why it's doing the whole pose processing. The face there is blurred out. I don't know what's have to look into that. That was just the sample code that was used, and we storing. So the pre-processing is storing the data, taking them out of these Parquet files and storing them into TF record files. It's for TensorFlow record, so different file formats. Then I don't 100% get this bit, but supposedly you need to mark each letter where it starts and ends. So you have a start token, end token, and just padding, I guess, in between when the hand is not moving, or between letters there's some padding. So that bit of code does that. Resizing. Yeah, so this one detecting a dominant hand from the number of NaN values. So supposedly when you can't see I guess none values will come up when you can't see that particular part location of the hand, and then this one will calculate which one has more nans, and then we'll take the other one as the dominant hand. Praise that from this function. Right, so the good thing about GitHub Copilot is that you can actually take, say, this code and go, you can fix it or just explain, and it will, in as legible language as possible, will explain what that bit does. Had to do a bit of some changes here that used to come up with all sorts of errors. This is out of OOV is out of vocabulary words. I'm not sure why they mention words, considering it's meant to be letters only. And I mean, this is what yeah, they're probably tokens. Yeah, that will be a better description. It's actually interesting. Yeah, before it was gave words. This is what the copilot is generating this description. So yes, have to make sure it's accurate. For some things, I found GitHub Copilot not to be so great. It just kept rambling on and on. Would not call it hallucination because I assume it's correct. I don't know any better. But I was also kind of double checking with ChatGPT itself, the free version. It kind of gives you a different perspective on what's what. Define above, create the final data set, train. So we split 0.8, so 8%, 20, I guess, for training and validation. Create the transformer model. So this is using automatic speech recognition transformer. And yes, when you enter this sentence into ChatGPT, it says, "Oh yeah, it's great. This is a great idea." So, so in the same way where you have speech, you digitize, process it, and generate words. In the same way, we will be putting in those images and spitting out text as well. So this is the main bit that's just setting things up for the transformer. This one doesn't have many comments. We can add more comments with embedding layer for tokenizing the input. Don't quite get it, but okay. Num vocab is the number of words in the vocabulary. Is it though? But we had 60 or so tokens. Max length is the maximum length of the input sequence. Considers different versions of this explanation. We'll just choose one of them. Now here there's the hidden dimension of the embedding outputs. Okay. Initialize the base, the base class. Oops. What did I? Did I? Oh, this run okay. Did I just delete something by mistake? No. No, this one's running okay. Embedding layer. So yes, you can put this one into try ChatGPT as well, and a copilot to explain the selected bit of code. What the GPT says.
It seems that the code snippet you provided is incomplete, as the token embedding class has an incomplete line of code for defining the embedding layer. However, based on the available information, I can provide a partial implementation of the token embedding class.
Well, yeah, that's why this will be better, because it will have the context, more context. I don't have a text to speech running there. There is a text to speech for. So we can try doing this. We can ask a. No, wait, question. No, the more questions that it's suggesting. No, explain below. Line below class. Should give an answer, ideally. The token embedding layer is a combination of an embedding layer and a positional encoding layer. The embedding layer converts tokens converts token indexes to vectors. Split it over. Split it over here. The embedding layer converts token indexes into vectors, and the positional encoding layer adds information about the relative position of the tokens in the sequence. The token embedding layer is used for the input data, and the landmark embedding layer is used for the landmarks data. I have to read more about it. Positional encoding layer. This class has a function as well. Call function for the layer. Anyway, where's code layer? The code layer. Anyway, I'll add the comments. I'll ask ChatGPT to add the comments to this code. And this is the bit, the training bit. We'll just quickly finish this and then add comments at another time. Okay, we'll convert in this. Right, so this is what the training is happening. And you have this target and this prediction. So that is wrong most of the time. You have this P for padding, beginning and end. Anyway, and then it's wrong most of the time, which is okay, I guess. training. We can explain this. Just pop it into ChatGPT quickly, so we don't have much time. We're not doing it properly. So here, for example, we can ask add plot labels, X level epoch, plot show. Do we need plot show? Loss epoch, that's fine. Explain the plot. I need to put question, explain the plot. The training loss decreases as the number of epochs increases. The plot shows the loss of a model over the training validation set. Split it. The loss model over training set decreases as the number of epochs increases. The loss of the model over the validation set decreases until epoch 8. Then increases slightly. This indicates that the model is overfitting the training set. Yeah, right. So after epoch, there's overfitting going on after epoch 8. So you could ask it how to prevent overfitting and things like that. So it's quite handy. Let's see how long this runs. You can also go a question, explain. Yeah, it's always reverts to what you wrote previously. The code below is used to save the model to a file. The model is saved to a file so that it can be loaded and used later without having to retrain the model. So we have a file somewhere. You can ask right, it's actually predicted my question. The model is saved to a file called model h5 in the current directory. Right, that's good explanation. Save weights to the same file. Right, we're obviously having that's folder is not correct. Model, need to find that file. Okay, working. But current directory. Right, I see. Yep, I see the file. Wait, the model. A working directory. So this is the directory. We need an set R in front because the slashes are the wrong way. To get rid of that, ask it to set this. Meant to be a working directory already, but yeah, doesn't want to do it. Anyway, we'll set this manually. R in front. This taking some time, I don't know why. Warning, TensorFlow skipping flow full serialization chaos layer found and trace functions such as update step flow assets and written in the temporary directory. So anyway, we'll let it run, see how it goes. Continue another time. Yeah, I'm trying to keep those live streams as short as possible. So see you next time. Bye. I wish this one had the text to speech. Text to speech only works. It only works for
zip submission.zip/model.tflight./inference.args.json.
The error message you're encountering indicates that the zip command is not recognized by your command prompt or terminal. The zip command is commonly used for compressing files and folders into a zip archive. If you're using Windows, the zip command is not available by default. However, you can install third-party software like 7-zip or WinRAR, which provide the zip command functionality. Here are the steps to resolve the issue. Install a third-party archiving software like 7-zip or WinRAR. Make sure to add the installation directory of the archiving software to your system's path environment variable. This allows your command prompt or terminal to recognize and execute the zip command. To add a directory to the path environment variable on Windows, right-click on the This PC or My Computer icon and select Properties. In the System Properties window, click on the Advanced System Settings link. In the System Properties dialog, click on the Environment Variables button. In the Environment Variables dialog, locate the path variable under the System Variables section and click Edit. Add the path to the archiving software's installation directory, example, C:\program whitespace files \7-zip, at the end of the variable value field. Make sure to separate the paths with a semicolon, winky face. Click OK to save the changes. After adding the
Anyway, I can do it myself. That model TF flight into one zip, is it? Compressed to zip file, and should be called and it's like 15 megabytes. So I did that manually, and there's this last bit. Hit the JSON file, prediction index. It's an SL fingerspelling folder. We obviously have it in a different place on our machine, and R there, and gave a prediction string. Yeah, and that's I assume is that the value what's called, it's the error. It's very large. So if I submit this, the score will be very low. So obviously we need to look at how we improve this thing. Hopefully ChatGPT can help. So I'll try this probably tomorrow. See you next time. Bye.